There are many groundwater resources that are non-renewable on a time scale of interest to us. It was water laid down over tens of thousands of years, like, to some degree, oil, although oil was laid down over millions of years. So we have non-renewable groundwater use in the Central Valley of California. I would suspect we have non-renewable groundwater use in Palm Springs. We certainly have it in the Ogallala Aquifer in the central part of the United States. In Libya, where the Libyans have spent $30 billion building a huge pipeline to pump deep fossil groundwater from southern Libya, laid down eons ago, very high quality fresh water, to where it's needed in the coastal cities of Libya. And that water will be used up over time. The North China Plains, India, there are places where we're overpumping groundwater in an unsustainable way, and groundwater levels are dropping, and over time, that pumping will become more and more expensive, and it will ultimately have to cease, very much like oil. Now, I want to introduce another concept, though, because there's another issue here, and we call it, I just wrote a paper on this with a colleague, and I'll tell you where to find it if you want, called peak ecological water. So imagine a very simple graph on the y-axis going up and down. We have the value provided by water, and on the x-axis, the amount of water appropriated by humans. So the more water we use, the more value we get. You can grow more food, you can make more semiconductors as you use more water. Now, this curve may or may not be linear, it may go up and then go down, but you get the idea that, in general, the idea has always been in our economy that the more water you use, the more value you can get out of it. And this is true of resources in general. But at the same time, there are ecological services provided by that same water. And the more water we humans use, the more we're taking out of ecosystems, and the more ecological value that water provides goes down. So ultimately, if you take all of the water out of a river, the fish die, or the wetland dries up, or some other ecological service, water purification, slows and stops. So something happens in between. There comes a point where these curves and concepts cross. And another way to look at it is, again, the x-axis is the amount of water appropriated by humans. The y-axis is now the total value, not just the economic value, but the social value, the cultural value, the ecological value of using water. For a while, the total value is going up. The human benefit, the economic benefit may be increasing, and you're not really affecting the ecological value that much. There does come a point when each additional increment of water used brings an overall net bad to the world. Now, part of the problem is we don't value these things the same way. One person's getting the economic benefit, and somebody else may be suffering the ecological harm. And that's a problem with our economic system. But somewhere, there's a point where if you use more water, the overall effect is bad, not good. And that's this concept of peak ecological water. So I mentioned earlier, we have renewable systems. You can use more and more water up until the sustainable level. Now, in fact, it might be appropriate that we don't use all of the renewable resource on the planet. That some lower level of use is really what we mean by sustainability. And that's a difficult concept, but it's a concept worth thinking about in the long run. And so that's this idea of peak ecological water. So we're not going to run out of water. The idea of peak water and peak oil are different in that sense. We're not going to run out of water, but we may run out of the ecological value that water provides. The climate problem is similar, to think about it that way. We're not going to run out of oil. We're not going to run out of coal. We're not going to run out of natural gas. We're not going to run out of fossil fuels. What we're going to run out of first is the ability of the atmosphere to absorb the consequences of burning fossil fuels. That's what the climate change problem is. It's a peak ecological problem. So long before we run out of energy, we run out of environment. And it's a different way of thinking about the problem than we thought about in the 20th century. And the problem's the same for water. So we'll never run out of water. It's mostly renewable. Where water's non-renewable, we'll run into stock constraints, and we'll have to move to renewable resources from those non-renewable groundwater resources. We will run up against flow limits that are a combination of natural constraints and, I would argue, economic constraints as well. And we are increasingly in regions of the world hitting or exceeding peak ecological water limits. We're doing it in California with the Sacramento-San Joaquin Delta, which is the heart of the California water debate for those of you who live here. The Everglades is a problem. The Aral Sea is disappearing. The Yellow River no longer reaches the sea in China. The Colorado River no longer reaches the delta in Mexico. We're running into peak ecological limits all over. All right, let me shift gears and talk about what this means for the economy, for the water sector, for investors. And let me talk about two things. There are risks to companies that depend on water. And those risks, I think, are both real and growing. And I would also argue that there are very few companies that don't depend on water for something. Some more than others, and I'll come back to that. And there are solutions and there are opportunities in the water sector for companies, for investors, and for the public. But they're sometimes hard to understand because water is sort of a strange resource. It has some odd characteristics. And let me talk about both of these. Water-related risks for industry. There is growing competition for water, and there are associated with competition for water worries about reliability. Companies use water to do things. Make clothing, grow food, make semiconductors. But there are other demands for water. 80% of the world's water that's used by humans goes to agriculture, irrigated agriculture. And the population's growing. We need to grow more food for more people. Now, are we going to do it with more water demand? Are we going to do it with more efficient water? I mean, these are difficult questions, but there is growing competition between agriculture, cities, and the environment, because in some places we're trying to restore flows to the environment. So there's growing competition and worries about scarcity and reliability. That's leading in places to limits on markets. There are sites that are water short. Beijing has announced they will no longer permit new industries that are water intensive to be built around Beijing. Textile industries, petroleum refining. There are a number of water intensive industries that you can't get a permit for around Beijing because Beijing is extraordinarily water short right now. That's a constraint on markets, it's a constraint on operations decisions. That's leading to difficulties getting and keeping permits for water operations in parts of the world. Water quality problems are leading to higher pretreatment costs. Some industries need very high quality water as inputs, like the pharmaceutical industry, semiconductor industry. If your water is very dirty, you've got to spend more and more water to treat it up front, not to mention treating it after you've used it to meet standards for wastewater disposal. That's going to lead to expenditures for treatment technology, both at the front end and the back end, depending on where you are, depending on the source of water you have, depending on what you're doing. There's enormous regulatory uncertainty about water quality standards, water quantity standards, planning, and that varies from different parts of the world. We have federal laws in the United States for water quality. We have the Clean Water Act and the Safe Drinking Water Act. Laws that were passed 30 years ago that set in place certain kinds of standards. But there are uncertainties about those standards as well, and I think we're past due time when those standards are going to have to be revisited and upgraded. And there are many parts of the world where there are no standards.